folks. Uncle Lee back here with you with the discussion today about the extreme value theorem. You know that Aep test is not far off. We need to start reviewing some of those topics that we've not touched on for a while. One of those topics is the extreme value theorem. The extreme value theorem is a very intuitive theorem in the study of calculus. By that I mean it should be somewhat obvious. So let's talk about the extreme value theorem. What is the extreme value theorem? And here's the other point that we want to make. You don't need to know the names of these theorems when you go to take that test. That's not the point of the test. The point of that test, and it is a very extremely valid test, the point of that test is to determine, hey, do you understand calculus? What does calculus do? Calculus helps us analyze functions. They used to call it math analysis. And a lot of this analysis is just intuitive. Once we start talking about functions and their domains and ranges and mins and maxes and extreme value theorems, or extreme values, and that's what the extreme value theorem addresses. You don't need to know the name of it, but you need to know what it tells us, and you can determine what it tells us. You know this without calling it the extreme value theorem. Let's see what it says. What it says is that f is continuous. You know what it means for a function to be continuous. Everybody does. You, we all do. On a closed interval. And you should know what a closed interval is. So we're only talking about function f from a to b, including a, including b. I.e. f of a exists and f of b exists. Well, the extreme value theorem says that if you have a function that's continuous on the closed interval, well, what do you know? Well, then f of x is going to have an absolute maximum. Sometimes some books call these global maximums, and an absolute minimum somewhere on that closed interval. If it's continuous, it's going to have if it's continuous on a closed interval, it's going to have an absolute max and an absolute min. It has to. Think about that. Sketch a function that's continuous. It's going to happen every time. As a side note here, let's look at the side note. Those absolute extreme values could happen at the endpoints. Some people, I've read many of those prior test student works, some people call it the endpoint test. Call whatever, well, don't call it whatever you want, but you can call it the endpoint test. Call it the extreme value test, call it the endpoint test. Call it duh, call it the duh test. Call it whatever you want it. But those extreme values could happen at the endpoints of that interval. Here's the key point. Well, or they could happen at the critical points within that interval. Now we have to know when some books, the book I'm using right now, call these critical points. Some books, the prior two books or 3 or 4 books that I've read, call them critical values. It doesn't matter. The critical points. What is critical point? That happens when the slope of the tangent line to that graph is 0, or it has one of those ouchie points, one of those cusps. Those are called critical points, where f prime is 0 or f prime doesn't exist. So those absolute extreme values could happen at critical points. I'm going to show you a graphical representation here in a minute. The absolute extreme values could be local max or local minimum. If they can happen at the critical points, that's where, well, Fermat told us that if you have a local max or a local min, then by golly Joe, those are critical points. If you have a local max or a local min, those are critical points. Well, those critical points could be absolute. We could also call those absolute max or absolute mins. In either case, the other thing that you need to know about this is that those extreme values are y values. They happen at x values, or t values, you're going to see in a little bit. But in either case, those extreme values are y values, function values, that happen at certain x values. So let's look at a graphical representation of the extreme value theorem. And you're going to think to yourself, well, duh, Here I have a function, a graphical representation of the extreme value theorem. I have an arbitrary function, and this arbitrary function is defined from A to B. And it is, what do I mean? I mean it is continuous. I can sketch it without picking up my pencil. Our first definition of continuity. And I see right here at the value C, this is a critical point right here, and I have a local minimum. And over here at D, I have another critical point. Ah! It's one of those ouchie points. That's a local max. C and D are both critical values. Since F prime is C, is 0 there, I have a horizontal tangent line right there, and I have the derivative that doesn't exist there. Continuity does not imply differentiability. Differentiability implies continuity, very important theorem. Anyway, so what? So this thing has an absolute max. It has an absolute y value from somewhere between A and B. Where is that absolute y value? Well, that absolute y value is going to be here. It's going to be f of d. That's going to be that absolute y value. That's the absolute y value. That's the absolute maximum value. Well, where's that absolute? And it happens at a local max. How about the absolute minimum? Well, here's a local min. Hey, the absolute minimum is right there. And it is f of b. Absolute max, also called global max, is f of d. It's the largest function value. The absolute minimum is going to be f of b. The absolute minimum. And keep in mind, f of b this time, well, this guy right here, I believe, was, yes, f of d. F of d was the local max. This was also called, I could also call this, for this case, a local max. For this case alone. So what I want to do is do two problems. I want to do one just an analytical problem, and then I want to look at a specific problem from a prior AP free response question. I want to point something out on these free response questions. But before I go there, let's just look at this guy right here. I want to look at this function right here, example number 1, f of x. 3x squared e to the x, and I'm only talking about this function on the closed interval from -3 to 1. Well, I know that the domain of this function without that is all reals. You can square anything and you take e to any power. So the domain of this is all reals, but I just want to look at this from -3 to 1. So therefore I know it is continuous from -3 to 1. And I want to find the absolute extreme values of f of x on -3 to 1. Well, if those absolute extreme values could happen at local mins and maxes, local extreme values, I better first and foremost find where those local mins and maxes happen at. But here's what happens, especially on the AP test. People forget about the extreme value theorem, they forget about the endpoints, and they only find the local max, and you get severely penalized. You don't get all the points. But the first thing you have to do, and the first thing most students do, is find the critical values, and they do find the local mins and maxes using the first derivative test, and we're going to do that. But don't forget the last step here, because I want to find the absolute extrema. And the last step here is to find the absolute extreme values using the extreme value theorem or the endpoint test. Call it whatever you want to call it. Don't call it whatever you want to call it. Call it the endpoint test or call it the extreme value test. Extreme value theorem, or just tell it, hey, I'm going to check the endpoint test. Okay? So, back to our problem. What do I have to do? I've got to find the critical values. How do you find the critical values? You set the rascal, you set the derivative, find the derivative, set the darn derivative equals 0. Okay? And at any time during this is the video. You can pause it. At any time, pause it. I'm moving forward. 3x squared e to the x. One thing I want to point out, hey, let's start analyzing that function. That's what we want to do anyway. Oh, this guy here, the whole function, or the whole domain, x squared is always positive. I know, is 3 positive? Negative. 3 is always positive. X squared is always positive. E to the x, e to the x, e to the x, e to the x is always positive. If I have 3 positive numbers multiplied together, it's going to be always positive. So this function is always positive. So if this function is always positive, it's certainly always positive from -3 to 1. Just throwing that in there. Let's find the derivative. This is a product, 3x squared times ex, product rule f prime g, plus, I'm writing it as fg prime because of the ex thing going on. F prime g is going to be 6x ex plus fg prime, 3x squared ex. And now I need to find the critical values. So I'm going to set that. If you need to pause the video a minute and find the product, that derivative, go ahead. I'm going to set that derivative equal to 0. Okay, so I've got 6 e to the x plus 2. How do you solve something equal to 0? You factor that rascal. So I'm going to factor out the greatest common factor of these two terms. The greatest common factor looks like it's going to be 3x ex. What do I have left? I have 2 plus x. 3x ex, 2 plus x. When is that equal to 0? Well, let me tell you something. When is 3 0? Never. 3 is never 0. 3 is always 3. Already determined that. When is e to the x 0? E to the x 0. The e to the x is never 0. E to the x is never 0. We need to know that. The graph of e to the x is never 0. So the only time this expression is 0 when x is 0 or when x is negative 2. Those are my critical values. And what I'm going to do now is I'm going to do a sign chart. The other thing I'm going to point out, this is all about the Aep test. And what is the Aep test? What are you supposed to do on the Aep test? Let's see. The Aep test is your opportunity to demonstrate to someone else that you understand calculus. That's all it is. These things are read by thousands of people that don't know you. They don't know you from Adam or Jane. So it's your opportunity to demonstrate, hey, I know some calculus. I know enough calculus to be worthy of some darn college credit. But one thing they told the reader several years ago, stop looking at sign charts. That doesn't mean sign charts aren't awesome. Sign charts are awesome. But it's the inference that you take from the sign chart. It's what you're going to say from the sign chart. So I'm going to set me up a sign chart for f prime. I'm going to go from negative 3 to negative 2. I'm going to go from negative 3 to 1 because that's the closed interval I'm looking at. But I'm looking at from negative 3 to negative 2, critical value. From negative 2 to 0, 0 critical value, from 0 to 1. I'm going to take some test values here. These are called test values. I'm going to go negative 2.5. And I'm going to put negative 2.5 in the factored version of the derivative. Now, if I put negative 2.5 in here, 3 is always positive, this is always positive, so I've got this negative 2.5, negative 2.5, and then 2 plus negative 2.5 is going to be negative. Negative times negative makes this positive. Let's just go on with my sign chart here. If I put negative 1 in the other test value between negative 2 and 0, put negative 1 in this portion is going to be positive. Positive, negative. Negative times positive is going to be negative. So the derivative is positive from negative 3 to negative 2. Negative from negative 2 to 0. And if I put 1/2 in, a value between 0 and 1, that's going to be it's all going to be positive. So what does this sign chart tell us? That's what's important. Well, what does the sign chart tell us? If f prime is positive between negative 3 and negative 2, what you want to say is f is increasing on negative 3 to negative 2 since f prime is positive there. That's what you need to write. You need to write that. And that's awesome. F is increasing because f prime is positive. That's what somebody wants to see. Maybe not necessarily on this particular problem, but when you do sign charts, that's what they want to see. What about this negative thing here? Well, this negative thing here, f prime is negative from negative 2 to 0. That says that f is decreasing on the interval negative 2 to 0 since f prime is negative there. F is decreasing, f prime is negative. F is increasing, f prime is positive. And here again I have f is increasing from 0 to 1 since f prime is positive there. And now what can I say? Now what can I say? And this is where I want to go with this. Since f prime goes from positive to negative at negative 2, what does that tell us? That tells us that f has a local max. F has a local max at x equals negative 2. What is that local max? That local max is, excuse me, that local max is f at negative 2, since f prime changes from positive to negative at negative 2. This is the first derivative test right here. And what happens here? What happens at that next critical point, at that critical point 0? That critical point 0, well, f prime changes from negative to positive. Therefore, f has a local min at x equals 0. The local min is f of 0, since f prime changes from negative to positive at x equals 0. So now I have my local min, I have my local max, and now I'm back to the original question presented. Find the absolute max and absolute min of that function from negative 3 to 1. Back to the absolute extreme value theorem problem. I want to find the absolute max of that function from negative 3 to 1. Call it the extreme value theorem or the endpoint test, or hey, I'm testing the endpoints. And so all I'm going to do is actually test the endpoints and test the critical values. I'm going to test f of negative 3, f of negative 2, f of 0, and f of 1. These two here, we already determined that f of negative 2 was a local max. And we're already determined that f of 0 was a local min. But they could be the absolute max and absolute min. So all you do is you have to find these function values. You put these guys back into the original function. Well, what is f of negative 3? F of negative 3 is 3 negative 3 squared e to the negative 3, 27 over e cubed, which is approximately 1.344. F of negative 2 is 3 times negative 2 squared e to the negative 2, comes out to 12 divided by e squared, about 1.624. And it makes sense that this value, and it's hard to see that without your calculator, that this value is greater than that, especially it's only 3/10 greater. But we know it's greater because we knew from that sign chart that f was increasing from negative 3 to 2. So this value right here had to be bigger than this value, because from negative 3 to negative 2, f was increasing. Therefore, this value had to be bigger. You will be asked to make inferences about that all over that AP test. What is f of 0? F of 0 clearly is 0. What is f of 1? F of 1 is 3/1 squared times e, which is 3e, approximately 8.155. And now you do this. You look at the values. And you find out which one is the smallest. And which one is the biggest. Who's the smallest? 0. Absolute min. Who's the biggest? 8.155. Y 0 is an absolute min, happens at 0. Y equals 3e is the absolute max, happens at x equals 1. And here's the graph of that function. Increases to 2. I have a local max. Decreases to 0. I have a local min, and then really start shooting up. Next question. The next thing that I want to look at, this dude right here. I want to look at 2009, the AP Calculus AP free response question. And you have to be careful when you read these questions. And here's the error I'm going to show you. And I'm only going to look at part B. I'm only going to look at part B. If you want to pause the video, if you want to go over to AP Central and check this question out, if you want to go to AP Central, I strongly encourage to go to AP Central so you can see you can see the free response questions from the last 10 years, plus the rubrics, plus student responses. Good idea. But this is the 2009. I'm only going to look at part B. And it says, find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. Is a maximum. Oh, wait a minute. They didn't say local or absolute. They just said max. They didn't say... Whenever you see the word just maximum or just minimum, what is implied is the absolute maximum or the absolute minimum. If they want the local min or local max, they will say local min or local max. If they do not say local max or local min, keep in mind those are also called relative extrema, relative low, relative max, relative min. But if they only say max, they want the absolute max. And you will see it. I'm going to let you look at the rubric. I'm going to show you how to go about doing just this part B. if you don't test the endpoints, this particular portion, there's 4 portions, A, B, C, and D. This part's worth 3 of the 9 points. 1/3 of the points available for this particular problem come from part B. 1/3 of the points. Your objective on any of these free response questions is to get as many points as possible. What do you need to do? You need to nail a couple problems, and then on a couple problems you need to get 5 or 6 points, and that's it. It's your opportunity to demonstrate that you understand calculus. That's what it's all about. It's not all about getting it all right. It never will. But I want to find the time with the rate at which people enter the auditorium as a maximum. Well, and then read the problem very carefully. Well, the rate at which people enter an auditorium for a rock concert, done that a lot, been there, woo! Rock concert is given by this function right here, between 0 and 2. And look at this is number 2. Number 1 and number 2 on the A, B, and or B, C test will both be calculator active problems. Good thing there's some big numbers here. This is 1 and 2 will be the calculator active problems. So that's all I'm talking about. That's the rate measured in people per hour. Let's forego the rest of the problem for lack of time. And all I want to know is when that rate is a maximum. I want the absolute maximum rate from 0 to 2. That's an extreme value theorem problem, ladies and gentlemen. A lot of people didn't get the point because they didn't check the endpoints. Let's go back to the active inspired sheet and look at this problem right here, number 2. This is 2009, number 2, part B. This is the rate they give you. This has a max, and the question is, where is the max? Where is max? Where is max of that guy? And it's only defined from 0 to 2. I find R prime. And keep in mind, this is, you could look at this, your calculator, and find the max with your calculator. That's not going to give you a point. You've got to say, hey, I know how to find the max of any function. I find those maxes happen at the endpoints or where the derivative is 0. You've got to consider, I ask you to look at the rubric, you've got to consider where R prime of t is equal to 0. So R prime is equal to this. You set that equal to 0, and you see right here that t is equal to 1.362963. At t equals somewhere after the first hour, 3/10. And here's the other key that I want to tell you about the AP. They say round to 3 decimal places, round to 3 decimal places, round to 3. Your teachers have been telling you that. Only round to 3 decimal places at the very end. At the very end. Don't round until the end. Up until the end, you leave as many decimal places. This is how many decimal places that my calculator gave me when I did this problem with my calculator as I did. But you do need to consider when R prime of t is equal to 0, or at least say R prime of t is equal to 0 at this t value there. However you find it, you have to say that to get that point. You'll see when you look at the rubric. And then I just check the endpoints and the critical value. I'm checking endpoint, critical value, endpoint. Endpoint, endpoint, critical value. They already told me that, well, at 0, nobody was going into the auditorium. Hello. They hadn't opened the doors yet. And at one point, at hour 1.362963, 854.53, that was the rate. And at 2, 120. At hour 2, about 120. And so what do you want to say? That the max rate, you have to have the conclusion, the max rate is 854.53 people per hour. They tell you, use your units. They give you the units, use your units. The max rate is 854.53 people per hour are entering that auditorium for that rock concert. I went to see Black Sabbath in the summer of 1973, and I can guarantee you it was festival seating. I don't think this was festival seating. They haven't had festival seating since the Who concert in Cincinnati. Not quite sure that was 75 or 76 something. Went to see Black Sabbath in 1973. I guarantee you that people was festival seating. People were entering that auditorium a lot faster than 854.53 people per hour. They were entering maybe 854.53 people per 5 minutes. you got to the doors and just shot through. Anyway, extreme value theorem, very important. It's an intuitive theorem. Very intuitive theorem. Go through this. You are going to be tested on the Aep test over the extreme value theorem. They're going to ask you somewhere along the line, where's an absolute max, where's an absolute min, or where's a max, and where's a min. We know that they're talking about absolute max and absolute mins. Thank you very much.